Good morning, Scott Crishane with Micom Americas for the United States, here with Martin Ishkananian from Micom in Toronto, Canada. We're doing some installation videos here today. Thanks for joining us. What we want to just quickly cover is the best way to secure the aluminum header to your frame system, your wall, or in this case a storefront, a glass and aluminum storefront system. The standard header is 39 inches, which is designed for 36-inch doors. We have a 51-inch header, which is designed for up to 48-inch doors. What we want to demonstrate here, this is a 42-inch door, so we're not going to be able to install this the typical way. So the best way to do the installation is to have the header go to the outside left jamb all the way over to the outside of the right jamb. And then we can secure this aluminum header all the way from right to left. So in this demonstration, okay, we want to show you, okay, this is 39 inches and what we need is a 46-inch if we want to do it so that it's the most aesthetically pleasing. However, many times this is what you're going to do. This is going to be, let's say, short, so the question becomes, how can I secure the aluminum header for the swing door operator to the wall, or in this case the storefront? So here what we do is, up there we simply put in an L bracket. Typically you have 1 inch from the face of the aluminum to the beginning of the glass stop. You can use a 1-inch wide tube by 3-inch high tube, or you can use simple L brackets. We're going to use aluminum because that's sufficient strength. Now, because we can go all the way over to the left-hand jamb, and we're going to put screws here along the top jamb, we only need 1 L bracket out at the end. But you do need one because you want this to be really strong and secure.
Exactly.
So in this case, you can simply see this is where we're going to mount it. And with the L bracket, you're going to have plenty of strength. Okay, thank you, Martin. Now, another reason why you might need to put up L brackets is our standard 39-inch, you can cut down to 31-inch. So if there happens to be obstacles over here, even on a 39-inch door, you might have to cut it down so that the header will fit up here. Now, these obstacles could be a mag lock. It could be simple electrical wiring box that happens to be in the way, if you will. Could be fire alarm sprinkler systems, who knows what. So this is where the 39-inch would go. And like I said, we could cut it down to as much as 31-inch. And in that case, we would simply put your L bracket right here, approximately right here. And screws here, and screws here, like 3 of them. Perfectly strong.
We made the pre-holes and we're ready for the installation, but just before we put it up, let's double check that jamb to jamb is 46 like our header was. Bang, 46 inches. We're ready for installation. Thank you, Scott.
You're welcome, Martin. Can I help hold this up here?
Of course. Now, you guys won't know this, but we're using Tech self-tapping screws.
Okay, let's stop for a second. Oh, you're going to get it?
Yep.
Okay.
Perfect.
I can't reach that high.
You let me know the left and right.
Yeah, I'd say you got it.
I just want to get that like that. Put a little pre-hole right there. It's okay, it's okay. Hold the header.
Oh, sorry.
It's okay. Hold the header.
Yep. I got part of it.
Thank you. It's okay. Just make my life a lot easier. Perfect. Perfect right there. Let that guy sit there. Reposition header. Perfect. Make your bottom flush to the jamb, which we have right now, which means you could put in your second screw on either side. Generally, 6 to 8 Tech screws will hold the header in very securely. Perfect. Now you got a strong header mounted to the jamb. Give it a little hand test, and you'll know that it's on secure.
And I would say some, again, this is a 46-inch one, so it's bigger than normal. Some installers will buy a big C-clamp because they'll do this job all by themselves.
Sure.
And then they just open this door and they run their C-clamp from here around to this side, and they'll C-clamp it up to hold it in place while you start your fastening.
Perfect. Before we put the motor and the board in, we get our packaging with the stickers and our on-off hold-open switch, which we'll install before putting anything up there. So like I said earlier, there's a little knockout hole. The smaller knockout hole is for our switch. So just grab a hammer and a flat, give it a couple whacks, give it a couple bends, and that guy's out of there. Perfect. It's going to come in this little packaging. Rip that open. Got it. Okay. So you're going to put in the adapter side first. Get it through the hole and set this up on the other end. Where's my little actuality? I need that first too. Like that. Perfect. Perfect. Let's get this guy on. You might need a little flat for the little wings that are on the sides. You just bend them in. Now you have your switch. Leave it in the off position, which is in the middle. The two dashes are hold open. One dash it's in automatic mode, which is labeled on the side of the header cover. Now that that's in, now we'll grab the board and reinstall this into the header. The two screws that were already sitting in the tracks. We'll bring this a little bit over because it's a 46-inch header. Let's set this one in. Tighten that in with a 7/16 wrench. Perfect. Not too tight, just enough where the board's not going to be moving. We don't have power at this moment. We will do the testing with an extension cord at the end of the process. But the on-off switch, it's a quick plug-and-play into this little terminal on the bottom of the board. That's just plugged in. The on-off switch is. If the on-off switch is not installed, and you're wondering why you can't do anything, you can't do any functions without this on-off switch put in. Just to let you know. Perfect. Now we'll grab the motor. Just the way we took it out, we're going to reinstall it. It's pretty easy. It's kind of made where we can put this in like kind of like set it and forget it, because it's once you get it up here, it'll sit up there, which is nice because, you know, there's other models where you gotta kind of keep your hand on it the entire time. Put the screws back in. Phillips. Back to the Phillips. Come on. Okay. So. Perfect. We got 2 more screws to put in. And then we'll show you the quick connect of the wires from motor to logic board. Everything's a quick connect. The last one is the one on the top track. Just align that little screw right into the hole and get the third one in there. It's more, if you forget this screw, your motor's not that secure. It's not lined up, is it? Perfect. So like I said, now that we have the board and the motor in place, I'll just come over a little bit so you guys can see this on camera. It's a quick connect with your connection on the outside for the motor. And then the rev counter that we spoke about earlier has the same male and female end on the logic board. Position that in and lock it into place. You pretty much have all your functions set up until we present power to the motor. Now that everything's in place, we got to get our push arm on. Unfortunately for this project, we have a garage blockage. This is the standard push arm that comes in the packaging when you order a left-hand or right-hand push motor. Just to show you guys the installation of the push arm, you're going to put your butt end 13 inches over from jam side, 2.5 inches down to the center. It goes your butt end plate. Then when you put on your arm on the spindle, you want a little bit of angle. So you got to bring it into about 70 degrees just to get better tension to push the door open. The more you're over that way, you're fighting more resistance. You put that guy on, put your screw back in, and it's ready. The good thing about the Micom motor is that's all you have to do until testing. You don't got to wind up the spindle at all. Perfect. The one that we're putting on today, because of the few inches of space we have from the garage, is our longer hockey stick shaped pull arm that's going to be running into a track that we're going to install on the frame. And this is the push. This is generally going to push the door open to 90 degrees.
Simple demonstration for helping diagnose a door when it's slamming shut. This is the way your normal door works. Closes nice, smoothly. If you ever have a slamming door, I'm going to remove the motor plug from the control board. If your door does that, then it may be as simple as the motor's not plugged into the controller. Even if there is no power to the control board, the motor cable has to be plugged into the controller.
That was great.
No more slamming door.
So now that we've installed the motor, got the push arm on, we've connected power to the motor, we now get to the programming, which is very, very simple on the Micom board. Everything is a click. Everything's selectable, deselectable. Let's begin. The first thing we're going to do with the Micom board is actually learn the door. because when you put the arm on, we are set up to now learn by hitting the test button, pressing the test button, clicking the test button, and holding it for about 5 seconds, releasing, and hitting enter, like the board says. Getting off the ladder. If you don't have a door stop, you will manually stop the door at 90 degrees. The door will close on its own. The door will set up its latch on its own. Now, to see how that worked without setting anything up yet, just click test for the full function from 0 to 90. Wonderful. So after our testing of the door, the menu digital board is a light up board once you press any certain button. Menu is our click button to set up all parameters. The door is already set to a default settings, which is in the operation manual, and those are set to default settings where the door will do its normal functions, but not to the necessary parameters that you might want on your project. Menu. You're going to see the Micom telephone number pops up. You know you're in business. Click menu again. And you have the opening speed, which factory default is 10. We generally leave that speed at 10. Click menu again. Back check speed of 3 is the default setting. The higher you go, the faster the door will back check at the end. The lower number you set up with the up or down will decrease the speed that the door back checks to 90 degrees. Click to the next one. Safety hold. Safety speed hold. You can guide through that one to the next one, which is closing speed. The default setting is set at 5. 5 is generally a pretty low number. You can go all the way up to 15. Now you're going to find out through your speed and you're setting up your 555 on an average 36-inch door. 5 seconds opening, 5 seconds holding, 5 second closing, to see if that's going to be the right parameter for your door and size and weight. The next function is latch speed, which is the ending of the door closing from generally 10 degrees to door close. And the default setting is set at 1. That's another number. It's a little low, but you'll know what you need once you figure out the parameters of your door through a few swings. The next setting is current limit, which factory setting is at 10. The next setting after clicking on menu is activation time. This is one of your most important activation on the program. That's the amount of time your door is going to stay open once it gets to 90 degrees. Factory default is set at 5, and you can go all the way up to a higher number for hospitals when they want the door to open longer. Click to the next menu. We are going to be at latch position. Latch position was the one I said that was at 10 degrees. You can raise that up. If you want the door to close, to start closing at the latch a little bit more, you raise it up to 12, 14, 16. But 10 is the default that the Micom factory has set up for us. Back check position. As we said already, the back check at the ending before 90, it's set at 80%, which is 10 degrees off of the 90. If you want to lower that to 76, 74, again, the up-down toggle, once you're on this position that we click to, you can go down, 76, up, back to 80. We'll leave it at the default for now. The next menu item on the menu list was the push and go feature, which we do not use the push and go feature. We'll always leave it at no, which on the Micom board is off. The next feature is power close. Power close feature, which is very unique and amazing to the Micom company and system and board, is a power closing mechanism at the end of the cycle when there's too much wind, negative air pressure, like in parking garages and in fire chutes, to combat the last force of wind to close the door or the air that's escaping through that area. The default setting has it off. And you will, depending on your situation, you will turn that on or off for your function of your door. The next parameter, the click on the menu, is power close force. This is the force you can use to close the door from 0 to 5. The default's set at 1, which is very strong. Going through the menu list, we now come to reverse obstruction. Reverse obstruction feature, another fantastic feature on the Micom board, is when somebody is walking or wheelchairing through a door and they took a lot of time and the door is now starting to come back, the door will touch you and reopen. It could be an object, it could be a person, it could be a wheelchair, so be it. The factory default has that off, and that's up to you if you want to turn it on or off. The next function on our menu list is the power shut, which is also a yes or no function. Same as the power close, the power shut has an amazing feature too, in that it is the force at the 90-degree point and on. Door opens up to 90, and now wind is just keeping the door open. The power shut function will fight that back check area and start closing the door from that point on. In the same way, the default is off, and you have a 0 to 5 range for the power. 1 is strong enough. Another great function that we didn't go through on the programming of the board is a factory reset. And you'd use a factory reset if you were to change your spindle angle to increase or decrease power on your door. After the installation, after you set everything up, it's going to go right back to the default settings, so you can start all over again. That being said, now that we've got everything figured out, we're going to go through each parameter for this specific 46-inch door, 42-inch door, 46-inch jam to jam, and to follow ADA guidelines for our opening, staying open, activating time, and closing time. Where's my little grip sheet? Okay, so from swing, we did a couple tests on the door manually, and you can see how strong, how fast the door closes. You judge it a little bit that way. See how the outside temperature is, the wind. Is there anything blocking the door? There isn't. So we're going to set up our back check speed to 1. We want it to close nice and slow at the end after it gets to 80 degrees. We want our closing speed a little bit higher than the default number of 5. We want it to close a little bit faster. For the people that come in, the door will close a little quicker than the default to match ADA guidelines. Latch speed is set at 1. We're going to set that a little bit higher to 5. Let the door latch a little quicker at the end. Current limit, we're We're going to bring that number down to 5. Activation time, the default's at 5. There is no scope of work that you're going to do that is that low. It's generally 6, 7, 8 seconds. We're going to choose 8 seconds on this project.
I like that.
And everything else is pretty much default. Our back check position, we're going to bring it down to 74 degrees. It slows down a little quicker than the default at 80. We don't want the door to slam a little bit at the end. So now we're ready for the test. Just click test once after setting everything up, and the door will do to the functions that we just programmed into it. See how it slowed down a little sooner? It's got open for 8 seconds, closing a little quicker, and latching much quicker. We do all this to follow the guidelines. On a 42-inch door, all of our parameters and numbers go up just a little bit from 555 to about 5.5 to 6 seconds in opening, staying open, and closing. And when we did the test on this, we got 17 seconds in full operation time, which we're going to set an example for right now. Scott, can you get your phone ready? Perfect. In 3, 2, 1. We'll time the entire process. You could do this with a stopwatch. Our iPhones all do this. Perfect. What did we get, Scott?
17 seconds.
17 seconds on the dot. The parameters that we chose for this specific door worked out perfectly. Every door is going to be a little bit different. Hopefully, you set it up properly on your project. Thank you very much. That's it for this. Okay, so now that we got the door completely tested, now it is time to add accessories, like a knowing act, a sensor, buttons. It's different for every project. On this project, we're installing the Micom's #1 Dart kit, 2 transmitters and a receiver with the HTB push buttons, the 4x4 stainless steel. Just want to give you a quick little on what comes in the packaging. The Dart little package, the kit, it has a little white box, which is the receiver. So the receiver is what I'm going to be showing you in a few minutes. That gets wired into the Micom logic board. Looks like this. It actually has 2 channels, channel 1 and channel 2. We'll be going through that in a second when we wire it into the board. And it's got the 2 transmitters for both push buttons, and they use AAA batteries, which we'll put in eventually. The push buttons themselves, nice little kit boxes as well. These come out like that. They got a nice little, they protect the stainless steel. Usually there's a little package in here. Yes, right here. On the side of the box, you're going to find a little baggie that's got the Allen key for us to actually take off the two little screws, loosen it up. That should pop right off. Perfect. Perfect. You're going to get the back box, the actual push button, and a little push plate that holds the push button in properly and hides the elements of water getting to the inside transmitter. So for this actual application, the knowing act that we're going to use are wireless push buttons. We went through opening them up, and now, as per ADA specifications, a push button needs to be 34 to 48 inches off the ground. Choose the middle of that. Choose around 40 inches. You're more than okay. As this is a right-hand push, we're going to use this left-hand jam. Actually, no, I'm wrong. We're going to use the right-hand jam for our internal push button at 40 inches, top dead center. Put a little mark. The same thing on the outside. The only difference is, as per specifications, the push button's got to be minimum of 2 feet, 24 inches from door opening, which means we can't use this jam. We're going to fly over to this one that's more than 2 feet away. Now we'll save that for later, as I'm going to get back up on the ladder and wire in the receiver to the Micom board. So it's 4 wires. 2 of them are activation, 2 of them are power, and then you have your antenna. So 4 that we're using, 1 is just an antenna. So on the Micom board, there's 2 terminal socket drives. One is 6, and one is a much bigger one that's got 12. All of our power inputs go on the 6 terminal drive. And you'll see on the left-hand side, 24 volt, 12 volt ground, normally closed, normally open, common. Because we're grabbing power to power up our receiver, we're power into the power lines. The Micom board, generally for a receiver, we tend to use the 12 volt terminal for power, which is the second one from the top of the 6 terminal drive. And then ground is the one right below it, which is 3rd from the top. And this will power up our receiver, and you'll know the red light is on the receiver. So you know you've powered it up to this point. The last 2 wires were activation. On the 12 terminal drive on the right side of the board, the bottom 2 functions are activation 1 and ground. Those are your activation inputs on the Micom board. For a general, if you were to wire a push button, the same way, they'd go into these exact 2 terminals. But since this is an exterior door, we generally use wireless push buttons for an exterior door because it's very difficult to get low voltage wire to the outside jams. Okay, I think that's in there. Perfect. Okay, so now that we got the push buttons installed on the inside and outside of the door, we get back to our receiver that we know is powered up because it's lit up red. And we're going to go to Learn 1, which is the top button. We're going to hold that for about 5 seconds. While it's beeping, now we press the button. Wait for it to stop and press it again. After the 3rd press, your door should activate. And you'll know, because all the red lights on the Learn 1 went off, it only lights up now on activation, which I'll show you again. It's already been set up. Now when I press the push button, there's the light up red, door opens. We'll do the same thing for the exterior button. Hold the Learn until it lights up red like that. It flashes. And we press once. We press again. The door activates. Both of our doors are now set up. Both of our buttons are now set up. We can give this a test by let the door close, and we'll do an actual push button press. From the outside, worked perfectly, because you always want to give it a few tests, because you don't want to leave a job site with you thinking that you got the doors activating And then you get a call back. Press it again. Perfect. And all of our parameters are still met. The door's still opening and closing at 17 seconds in total time. You'll constantly check for that during your installation day. Perfect. After the installation of the TopScan 3, we are now running the wire through our header, which we had quick connected to the bottom base there. We'll strip the wire here. And it's a 5 conductor. We are not using the green. The green is for normally closed. You can cut that off. The red power is going to go to our 24 volt terminal, which is number 1 on the 6 block. The black ground is going to link to the ground wire we already ran from our wireless receiver into the third on the 6 terminal block. That's ground wire. So now we have a brown and a white left. The brown is our normally open, but in this scenario, because we're using this as a safety scanner, this is getting inputted into activation 2. Which is third from the bottom on the 12 terminal block. And the last white wire is going to join up with the ground wire on the last terminal on the 12 terminal block. Because we had the ground from the receiver there. We'll just link them together now. Perfect. Okay, that's all wired in. You want to hide your wires, tuck them in. The cleaner the better. Perfect. Now we will turn our operator on. We always turn it off for wiring purposes. We will try our push button. The door will open. Now we'll play off the safety sensor. I'll act as a human walking through. The door reopens. We'll try it again. Beautiful. That's wonderful. So that shows you the purpose of the safety sensor on how it sensed me being anywhere close to the door opening, so the door would reopen as it sensed me. Is it on?
No.
Oh. Okay. Try that out. And when installing the safety sensor, it is on. Perfect. It is on a system where you can actually dial your degrees to lower and higher to spread out. In this scenario, we're catching somebody underneath the door or on the safety side. So we have it pretty low degrees. And you also have a slide to left and right on the sensor. So since we're activating, we want the safety zone closer to the right. We had push the sensor more to the right in the track. And that's a complete sensor with operator function on the Micom motor.
Hi, Scott Kershane again with Micom. We want to just demonstrate to you how simple our battery backup option is. It literally is two 12-volt batteries
like a virtual car.
The charger. It's like a trickle charger. We're going to plug that into the controller, and then we're going to plug the two batteries into here. And then the really neat thing about our battery backup is we have a built-in relay on it. This relay gets triggered when the two batteries cannot maintain more than 17.8 volts. So it basically, if you hook this up to a central command system, the relay, it'll send a signal to the central command and it'll say, hey, you got to change your batteries. If you don't hook it up to a central command system, then it's like any relay. You're going to hear a little click, 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 click. So if you walk under your Micom automatic door 2, 3, 4 years down the road and you hear a click, 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 you might need new batteries. So here's our 2 batteries.
You can hook those up first if you want.
Yeah.
Yeah.
They simply, and you cannot, these are keyed, so you cannot get them, you cannot connect them incorrectly.
Plug and play.
And again, the same.
It's being stubborn.
It is. And with my fingers.
Let me see. Is it? It's the correct way. Yeah, there you go. There it is.
Okay, so we got our 2 batteries.
Let's find a nice spot to set them in.
Yeah.
In the header.
And it could be literally right here.
Yep.
There's plenty of room. Or if we moved it over a little bit. And then right here is the little battery backup connection. You plug it in and that's it. So the intentions of the battery backup is to provide enough cycles when the building loses power for the pedestrian occupants to be that are in wheelchairs or slow moving or to be able to egress the building safely. That's the intention. We have other options where you can get much bigger batteries. You'll have to put them in a remote place. But if you had a requirement that you had to have 150 cycles or 200 cycles, we just have to come up with a different battery solution for you, which is really honestly no big deal at all. So that's it. It's as simple as that. The really good thing is, if you pitch your customer on the need for this, which I say the need for this is if you knowingly have an employee or a regular customer that is in a wheelchair or a walker or a slow-moving pedestrian or an employee that gets an injury, again, that's slow-moving, that's when you need to have the battery backup. Because if you have loss of power, if you do not have a whole building backup generator, then you want to be able to provide them emergency egress. However, I'm sorry, lost my thought. Give it a second. If they choose not to get battery backup, you can add it anytime. It's literally as simple as the plug and play that I just showed you. So whether they buy it immediately or later on and add it.